These are the 7.3 part 1 notes, and we're going to start learning about trigonometric identities. Now, this is not the easiest topic in class. This is something that I would honestly argue is probably the most complicated thing we're going to learn all year. And that's because there's a lot of guess and check. There's a lot of algebra with trig applied. So we're taking the trig properties, which we've learned. We're taking a lot of the trig identities we've learned, and we're starting to do some algebra with them, and we're starting to kind of make some proofs. And when we're making these proofs, we're not doing proofs like we did in geometry. We're not writing down what the theorem is. We're not writing anything down like that. We're just kind of doing pure math. So this is proofs. This is taking one trig principle and proving another trig principle via other trig principles in between. It's a lot of guess and check. It's a lot of knowing the properties, trying to figure out when and how they can be applied. It's not something that comes right off the top of your head. I've had this conversation with many math teachers that this is one of the more difficult concepts, not in the sense that it's hard to understand what you're doing, but sometimes figuring out what step you need to apply when and where can be difficult. I can even recall sitting in Calculus BC, so sitting in my second year of calculus, having been doing this for 3 years and still being confused and still not being sure of which property to use when. It takes a lot of time. Even now, I have to slow down sometimes and really ask myself, why am I using this property? Or really look at a problem for a few seconds to a couple minutes and say, what properties do I know? Where can I work from here? Sometimes you make roundabout ways of getting to the answers. Other times you make direct ways of getting to the answers. Everyone's going to kind of go at their own speed. It's okay if this is taking you a little bit longer than you think it should be, or it's taking a little bit longer than your normal homeworks are. This is not something where we know what the end goal is, and figuring out the middle can be more difficult. So let's actually kind of start looking at what these are. And the book does a pretty good job of breaking it down. They introduce the idea of we're just going to start breaking some things down. So first, I know that this is some groundbreaking mathematics here. We have the equality property, which means that two functions are identically equal if we say they're equal. So if f of x is equal to g of x, that means that they are referred to an identity. So any equation that are identically equal can be referred to as an identity. And any equation that is not an identity is called a conditional equation. So in trig, we already know a series of rules, and from those series of rules, we can prove some other rules. So here are the trig properties reminder. These are the trig properties we know so far. We're going to be adding a few more theorems and formulas over the last couple weeks of the year. But these are the ones we do know. We have our quotient identities of tangent being equal to sine over cosine and cotangent being cosine over sine. Cosecant is 1 over sine, secant's 1 over cosine, cotangent's 1 over tangent, just as sine is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. Sine squared theta plus cosine squared theta is equal to 1, tangent squared theta plus 1 is equal to secant squared theta, cotangent squared theta plus 1 is equal to cosecant squared theta. The sine of negative theta is equal to negative sine theta, cosine negative theta is equal to cosine theta, tangent negative theta is equal to negative tangent of theta. Cosecant of negative theta is equal to negative cosecant of theta. Secant of negative theta is equal to positive secant of theta. And cotangent of negative theta is equal to negative cotangent of theta. So these are all of our trig properties, and we're going to start using them to simplify, etc. And here's where the book, I think, does a pretty good job of starting us off. They just give you some instructions on what to do. So they kind of ease you into the idea of what we're doing. So before you start proving things, they just start having you practice. So for this first one, simplify cotangent theta over cosecant theta by rewriting each trigonometric function in terms of sine and cosine. So all it wants us to do is turn this into an answer that has only sine or cosine in it. What we do is I'm going to go through the process of saying that the cotangent of theta is equal to the cosine of theta over the sine of theta, and the cosecant of theta is equal to 1 over the sine of theta. So now what we have is we're talking about the cosine of theta over the sine of theta being divided by 1 over the sine of theta. That means I'm talking about the cosine of theta over the sine of theta multiplied by the sine of theta over 1. and these sines thetas cross out, so I'm left with cosine theta. And that's what the answer is. This is simplifying it. So all it's asking us to do is simplify. We've done this before. And when I simplify this, I prove that this is the cosine of theta. We've kind of done similar things with opposite and adjacents, but we haven't done it purely in the sense of working with our trig functions as trig functions. We've kind of worked with numbers. Now we're actually using them as trig functions. So it's just simplification. It's rewriting it. The book even told us to rewrite it as sine and cosine, which made it a little bit easier. And we were able to show that cotangent of theta divided by the cosecant of theta is just equal to the cosine of theta. The book is starting to show us what an identity is. So when we do trig identities, we have two trig things that are set equal to each other. And basically the book is going to tell you that it's an identity. Everything that's presented in the book is an identity. For almost every intent and purpose is actually an identity. It's never asking you true or false, this is an identity. They just straight up tell you, these are equal, now prove it. And that's what we're being tasked with. Now, right now, again, the book is easing us into it. They're telling us what to do. So it's saying multiply the numerator and the denominator by 1 minus sine theta. When we work with these, we are working purely on the left side. So we do the left side of the equation and we apply everything to the left side of the equation to prove it. So show that these are equal. I'm going to multiply 1 minus sine theta over 1 minus sine theta times the cosine of theta over 1 plus sine theta. This is completely allowed. This is just like algebra. This is just like anything we've ever done before. 1 minus sine theta over 1 minus sine theta is 1. So multiplying anything by 1 is legal. We can make 1 look however we want to make it look. So now when you multiply out fractions, remember you multiply across the top. So I've got cosine theta times 1 minus sine theta over 1 minus sine theta times 1 plus sine theta. Well, I'm not really sure what I want to do here quite yet. I could. Now, you're going to be really tempted here to cross out the 1 minus sine thetas. That's something that you're really tempted to do, but we don't want to do that because we just multiplied by that. So that's going to get us back to our original spot of that cosine theta over 1 plus sine theta. So I'm not going to do that. I'm actually going to go ahead and stop, and I'm going to multiply out my denominator. And what I see with my denominator is it's a difference of squares. So I'm going to be able to jump kind of the middle step. But again, all I'm doing is expanding both of these. So I'm multiplying 1 times 1 times sine theta, etc. And when I do my difference of squares, since I see that I'm doing 1 minus a number times 1 plus that same number, I get the cosine of theta over 1 minus sine theta. And this is all over 1 minus sine squared of theta. If you need to go ahead and do that expansion and get the 1 minus sine theta plus sine theta minus sine squared theta, you can go ahead and do that. Now, what I'm looking at here is this 1 minus sine squared theta. If I go back up to this property of the cosine squared theta plus sine squared theta is equal to 1, well, I can subtract sine squared theta on both sides, and this ends up becoming the exact same thing as cosine squared of theta is equal to 1 minus sine squared theta. That's an equivalent statement. All I did was move the sine squared over the other side. And I look down here and I see that I have 1 minus sine squared theta there. So that means that I can rewrite this as the cosine of theta times 1 minus the sine of theta all over the cosine squared of theta. My end goal here is to make this 1 minus sine of theta over cosine theta. I can cross out this cosine with that squared, and I'm left with 1 minus the sine of theta over the cosine of theta. And wouldn't you know, my end goal was to make it look like this. I bring that down here, and they're the exact same. They're equal. So I have this equal. That checks out. I've proved it. I just went through the process of multiplying by 1 minus sine theta. Now, the book told me that this would work. I was given this information. That's something that within a few problems I got to start being able to recognize on my own. I have to start seeing what should I do to make this work. It takes a little bit of time, but don't worry, you'll get there. Again, this is just kind of the book having us practice our algebra practice, our trig identities here. Simplify 1 plus sine theta over sine theta plus the cotangent of theta minus the cosine of theta over the cosine of theta by rewriting the expression over a common denominator. Well, this is practicing your algebra. We're going to multiply cosine theta over cosine theta times 1 plus sine theta over sine theta. And that's going to be added to the cotangent of theta minus the cosine of theta all over the cosine of theta multiplied by the sine of theta over the sine of theta. Now I can multiply both of these by these separate terms. I'm still multiplying both of these by 1. I'm not changing what these are in their basis. I'm just changing the way they look. So now I have the cosine of theta plus the cosine of theta sine of theta over the cosine of theta sine of theta. And I'm adding this to the cotangent of theta times the sine of theta minus the cosine of theta times the sine of theta all over the cosine of theta sine of theta. So now I can add these because I'm just going to add them across my numerator because they have common denominators now. So the denominator stays the same. Remember, when we add fractions, you don't change your denominator. Your denominator remains the cosine of theta sine of theta. I'm going to add these across. Well, when I add these across, this negative cosine theta sine theta crosses out with the positive cosine theta sine theta. So I'm left with the cosine of theta plus the cotangent of theta times the sine of theta. Well, I can rewrite the cotangent of theta, and I'm going to call this the cosine of theta plus the cosine of theta over the sine of theta multiplied by the sine of theta, because cotangent is equal to the cosine over the sine. And this is all over the cosine of theta sine of theta. These signs cross out. So this becomes equivalent to the cosine of theta plus the cosine of theta over the cosine of theta sine of theta. That's 2 times the cosine of theta all over the cosine of theta sine of theta. The cosines cross out because I have 1 in the numerator and 1 in the denominator. That leaves me with 2 over the sine of theta. And I can rewrite this as 2 times 1 over the sine of theta. And 1 over the sine of theta is equivalent to cosecant. So this becomes 2 times the cosecant of theta. So we proved that this really complicated thing up here, which looks fairly difficult, and it's a lot of thetas, it's a lot of work, it's just going to end up giving you the exact same answer as if you took the cosecant of that angle and multiplied it by 2. This is actually kind of cool. We went through the process of simply just finding a common denominator and adding them, and we were able to break that down to 2 cosecant theta. I know that seems tedious, it might seem weird, but it really does serve a purpose, and it goes through to really show that we understand our trig. And it also simplifies that a lot and shows how related all of these angles actually are. Okay, here we've got sine squared theta minus 1 over the tangent theta sine theta minus the tangent of theta, and the book is asking us to simplify it by factoring. So we're going to apply the exact same concepts with factoring that we've always had. I've got a difference of squares up here with that sine squared theta minus 1. This is the exact same thing as x squared minus 1, except I'm thinking of x squared as sine as opposed to x. So that means I can rewrite this as the sine of theta minus 1 times the sine of theta plus 1. And this is going to be over the tangent of theta times the sine of theta minus 1, because I'm taking the tangent out of both terms in that denominator. Means I can cross that out, and this becomes the sine of theta over the sine of theta plus 1 all over the tangent of theta. And then I can rewrite this some more. It's only asking me to simplify by factoring, so theoretically this could be a final answer because all I've done is factored and crossed out, so that would be a simpler term right there. I could go through the process of getting rid of the 1 and turning this all into trig functions here. So I can call this the sine of theta over the tangent of theta plus 1 over the tangent of theta, because that's separating my numerator as addition into common denominators. So this is the sine of theta divided by the sine of theta over the cosine of theta, which is the sine of theta times the cosine of theta over the sine of theta. Those sines of thetas cross out. I can rewrite this 1 over the tangent of theta as the cotangent of theta. And then I could turn this into the cosine of theta plus the cotangent of theta. So it really kind of depends on how far the book would ask me to go, or how far somebody would, or any worksheet, any question on a quiz or a test that would ask me to prove the identity. Theoretically, it could have the sine squared theta minus 1 over tan theta sine theta minus the tangent of theta is equal to the sine of theta plus 1 over the tangent of theta, and you would know just to factor and get there. It might have the sine squared of theta minus 1 over the tangent of theta sine of theta minus the tangent of theta is equal to the cosine of theta plus cotangent of theta. You might have to prove either one of those. Again, when all the book is asking us to do is ask it to simplify by factoring, either one of these theoretically could be correct answers. It becomes a lot more clear when you're actually doing the trig identities and you know what your end goal that you're trying to prove is. And here's what I mean by that. So establishing identities. So this is where, after you have a few practice problems from the book telling you what to do, you just kind of start applying the knowledge. So it's saying, show that the cosecant of theta times the tangent of theta is equal to the secant of theta. So what I do here is I start asking myself, what are some things that I can do with this to get me to the final answer to prove that I have these equivalent? Well, what I'm going to do is I'm only going to mess with the left side of the equation. I'm not messing with the right side of the equation. I'm first going to try to rewrite the cosecant as the sine of theta. I'm going to multiply that by the sine of theta over the cosine of theta. A really good rule of thumb is whenever you see anything that's not sine or cosine is to rewrite it in terms of sine or cosine. That usually is a huge help. That's like kind of trick one, step one of any trig identity, is always rewrite things in terms of sine and cosine, because when you have things in terms of sine and cosine, they usually simplify a lot easier. This is written, all these worksheets, books, etc. are written by mathematicians. They're writing things in kind of friendly terms, but at the same time, you have to put them in your own friendly terms, and more often than not, those friendly terms are sine and cosine. That's usually a good start. When I multiply these out, I see that these sine thetas cross out, so I'm left with 1 over the cosine of theta. And 1 over the cosine of theta is, in fact, equal to the secant of theta. So now I have the secant of theta is equal to the secant of theta, and that checks out. So that one was a pretty straightforward, a pretty easy identity. All I needed to do was rewrite everything in terms of sine and cosine, and it immediately worked out for me. And the first few identities you're going to get in tonight's homework are pretty straightforward and pretty easy like that, and can be kind of accomplished that simply. Now my next identity, establish the identity that the sine squared of negative theta plus the cosine squared of negative theta is equal to 1. Well, the first thing that I can do is I can state that the cosine of negative theta is equal to the cosine of theta. So the cosine of negative theta squared is just going to end up being the cosine of positive theta squared. That one's really easy. That one doesn't change. What I can do for the sine of negative theta is the sine of negative theta is equal to the negative sine of theta. And remember, when we say sine squared of negative theta, what we're actually referring to is taking that sine of theta and then squaring it. Remember that I have this negative times the sine of theta and it's being squared. Negative times a negative is equal to a positive. So the negative sine of theta squared is equivalent to the positive sine of theta squared. It doesn't change. These are equivalent values. So then that means that that is just equal to the sine squared of positive theta as well. So now I have the sine squared of positive theta plus the cosine squared of positive theta equal to 1. And we've already learned all the way back when we first learned about some trig identities, the sine squared of theta plus cosine squared of theta is equal to 1. So now we have 1 is equal to 1, and that checks out. So we can see here that this didn't even require us to rewrite anything. This just, we use the even-odd principle for this one, where we just turn that into a positive cosine squared theta. That worked out fairly well for us. The other one we just applied, not even algebra. This was pre-algebra. This is knowing how squares work. This is knowing negative times a negative is equivalent to a positive. All we did was apply some like really basic pre-algebra, really basic arithmetic, and we were able to prove this. So this isn't something that's groundbreakingly difficult. It's all right there. That one's pretty straightforward and pretty easy too. Tonight's homework are pretty straightforward trig identities. We're kind of easing you into this. All right, so now we've got the establish the identity, the sine squared of theta minus the cosine squared, the sine squared of negative theta minus the cosine squared of negative theta over the sine of negative theta minus the cosine of negative theta is equal to the cosine of theta minus the sine of theta. All right, so the first thing that we can do, we've already established from the previous slide that the sine squared of negative theta is the exact same thing as the sine squared of positive theta. I'm not going to go through that proof again. I theoretically should do this with each individual problem, but I've already proved this in the previous slide, so you know that. And then when I subtract the cosine squared, again, any cosine of negative theta is going to be the same as the cosine of positive theta. So I'm subtracting the cosine of positive theta here as well. I'm using my even-odd property for that. Down here, I'm going to move, and I'm going to use my even-odd property, and I'm going to say that, okay, this is the same thing as the negative sine of theta. And then I'm subtracting the cosine of negative theta, or of positive theta, because the cosine of negative theta is the same thing as the cosine of positive theta. So I'm just subtracting my cosine of positive theta from that. I look up top and I see that I have a difference of squares. So I say, all right, I've got the sine. I factor that out and I say that I've got the sine of theta minus the cosine of theta times the sine of theta plus the cosine of theta. Again, this is kind of like me saying up here that I've got a squared minus b squared, and whenever you have a squared minus b squared, that simplifies down into a minus b times a plus b. That's called the difference of squares. We've learned it, we've used it before, we've applied it a lot. Now we're doing it with trig functions. On my denominator, I'm going to factor out a negative 1, and I'm going to call this negative 1 times the sine of theta plus the cosine of theta. And I look up here and I realize, oh, this entire term crosses out. I've got it on the numerator and the denominator. I'm multiplying these out so I can cross it out. So now I've got the sine of theta minus the cosine of theta over negative 1. That means I am looking at the negative sine of theta plus the cosine of theta. And that turns into the cosine of theta minus the sine of theta. And right from the very beginning, we were trying to prove that this is equal to the cosine of theta minus the sine of theta. And that checks out. So there we go. We've proven that trig identity. All we did was we applied the even-odd principle, which we already had done in the previous slide, to those sine squared and cosine squared. And I factored them out as a difference of squares, factored out a -1, and then went through my arithmetic. If these notes haven't been super straightforward and you've been confused at certain places, I really want to emphasize that is A-okay and that is to be expected. Again, this is not straightforward. This is not the easiest concept. You're applying almost your entirety of your mathematical knowledge up to this point right now. It's almost as if we've taken everything that you've ever learned in math and applied it all in one spot, with the exception of like knowing how angles relate in geometry. But when it comes to all of your arithmetic, all of your factoring, all of your algebra skills, everything comes into play right now along with trig. So this is something that's brand new. It's something that is this is proofs applied with some heavy algebra, with some heavy trig. Not the most straightforward thing. The homework assignment does set you up pretty well. Numbers 9 through 18 are the book kind of telling you what to do. And then number 19 through 27 is you going through the process of actually proving these identities. And I give you some pretty straightforward ones. You're not doing anything super complicated. You're not throwing in any additions. When we take notes next week or on Friday, you'll kind of start learning some of these more complicated ones. But again, do not fret if this has not been the most straightforward thing. We're going to practice it, and we're going to practice it a lot. Please reach out with questions sooner rather